Hi guys, welcome to your thermal energy chapter 4 notes. These are going to be your last notes of thermal energy, so let's make sure we make them count. Your EQ for this chapter is how does thermal energy affect our everyday lives? So let's get things going. Remember, this is the notes overview. We're going to go over the key concepts from the entire thermal energy unit. There's 8 of them, so we're going to make sure we go over them, make sure we understand them. Insulators and conductors, ocean temperatures and convection, and albedo and radiation. So we're going to take that idea of conduction, convection, and radiation and apply them to some scenarios that affect our everyday lives, because that's going to really give us an understanding about our AQ of like how does thermal energy shape pretty much the entire world around us. So let's get things going with our key concepts. So this is part 1 of your key concepts. So objects are made of molecules and atoms. That's something we established at the beginning of the year, and that should become very natural to you at this point. Temperature is the measurement of the average speed of the molecules, atoms in an object. And so when we say speed, you can also remember that we're talking like kinetic energy. When an object raises in temperatures, the molecules / atoms in that object move faster, aka they have more Ke. When an object lowers in temperature, the molecules / atoms in that object move slower, and that means they have less kinetic energy. So all these go ahead and focus on the idea of temperature, which is just that idea of that the higher the temperature, the faster they're going, or the more Ke they have. And then the adverse, which is the lower the temperature, the slower they're going, or the less Ke. So let's go to thermal energy unit part 2 for key concepts. So these are the last of the key concepts that we covered. The amount of thermal energy in an object is equal to the total amount of kinetic energy or movement of the atoms or of the molecules / atoms in an object. So the key word being here total. When two things are in contact, their molecules collide, and kinetic energy transfers from the faster moving molecules to the slower moving molecules. In other words, that's the idea, guys, of high temperature to low temperature. That's the idea. That's a pattern we established. So that's the idea of, the stove burns you, you don't burn the stove. Next one, energy isn't created or stored. Therefore, as energy transfers and increases in one object and decreases in the other object. And then the molecules between these objects will transfer energy until the system reaches a stable state known as equilibrium, in which all the molecules are moving at the same speed. So this is that idea of thermal equilibrium. So those are all the key concepts. Those are the major things that we should have taken from this unit and ran away with and learned. But let's go ahead and add the ideas of conductors and insulators, and this whole other idea of convection, radiation, and albedo. So insulators and conductors. You might have heard these words before. They're used a lot in electronics, but they have a slightly different meaning when it comes to thermal energy. So as a review, conduction is heat transfer between matter that physically touches. So when things are touching, there will be heat transfer if their temperatures are not the exact same. But an insulator is an object that forces thermal energy to transfer slowly from one object to another. For example, a cooler. So like all these Yeti coolers, what they do is that when you put, ice in there and like, soda or whatever, and what happens is that the insulating or the insulation of the cooler will stop the thermal energy from the air getting to your ice. And what that'll do is that'll keep everything in there as, I'm going to say the bad word, but cold or as low of a temperature as possible, because we've insulated that thermal energy from other thermal energy, or those temperatures from other temperatures. And then we have a conductor is an object that allows thermal energy to transfer quickly from one object to another. So for example, pots and pans, if you've ever cooked anything on the stove before, your pan will heat up rather quickly. And that's a good thing. You don't want to have to be cooking all day. If you used an insulator, that the energy from the stove will slowly transfer through to the pan, and then that will slowly transfer to like your eggs or your pasta or whatever you're cooking. So conductors are a quick transfer of energy, and insulator is a slow transfer of energy. So now that we have a good example of conduction and with the idea of insulators and conductors, let's review something with convection. So convection, once again, is a heat transfer in a fluid, which is liquid or gases because of density differences. And that, remember that idea of density we learned at the beginning of the year is how compact something is with their atoms. So something with a high density is very compact, and something with a low density is nice and spread out. But convection explains why ocean temperatures are highest at the top and lowest at the bottom. And the reason why is because high temperature water is less dense and floats to the top. That higher temperature spreads out. And we're going to cover a lot of this in our next unit of phase change. And then low temperature water is dense and sinks to the bottom. So this idea of convection explains a lot of things that happens in our oceans, our pools, our lakes, and all that good stuff. So let's go to radiation then. So radiation is heat transfer through absorption of infrared waves. And I want to explain that to you in like the actual science of what happens. And we're going to cover this a lot in our electromagnetic unit, all about light, which involves infrared waves. When objects absorb the energy in infrared waves, the energy is transformed into Ke, which makes the molecules, atoms atoms in that object move faster and thus raises the temperature, proving that thermal energy has increased in that object. So the idea is that an object absorbs infrared waves and that energy gets transformed into Ke, and it makes the molecules atoms move faster. And thus it has more thermal energy and also a higher temperature reading as well. Now, the thing I want to bring up with radiation is this concept of albedo. And be prepared, this is going to be on your Chapter 4 quiz for sure. But albedo describes how well objects reflect thermal radiation or infrared waves, however you want to put it. Low albedo from dark colors means little reflection of radiation and thus more thermal energy is transferred. So for example, is that the sun, if it shines on this side of the mountain where it's all darker colors, such as, the grass and the dirt and the trees, it will absorb that energy rather quickly because it's not reflecting it away. It has a low albedo. If it has a high albedo, that means that it's going to be very reflective. And so high albedo from light/shiny colors means a lot of reflection of radiation and thus less thermal energy is transferred. So with all the snow, like on this side of the mountain, it's that radiation, that infrared waves, they hit the snow, but because it's shiny or it's white and it's a light color, a lot of it gets reflected right back into outer space. And so objects/areas with low albedo, it means more absorption, will have warmer temperatures. And then objects/areas with high albedo will have cooler temperatures. And we're going to talk about in just a second areas that have low albedo, such as cities, where a lot of things are dark colored buildings and streets. We have issues in cities where they get really, really high temperatures in the summer that become unsafe. And we need to start coming up with ideas to increase that albedo or increase the reflection. So just some ways that albedo affects your life. So in the summer, you want to avoid wearing black because black absorbs more thermal energy radiation. And that's that whole idea of albedo, is that dark colors absorb more. Roofs in Florida are made of materials that have lighter colors so that they can reflect more solar radiation. If you've ever driven through Florida before, you'll see a lot of tan color roofs or tiled roofs and stuff like that. And the whole idea is that they want to reflect a lot of radiation away rather than being like black tar roofs or like shingles like what we have in our area. Now you will find those, but a lot of homes have tried to avoid shingles that are dark colored because then they have higher temperatures in their homes that they have to work and pay more with their air conditioning bills. Coolers are usually painted white because that helps keep the cooler from absorbing too much thermal radiation and melting your ice. So if we go back to that idea of insulators, out of all of these, the best one to really buy is this white one. You wouldn't really want this blacker or this gray, like darker colored cooler as much as you would want a white version of it. While it might look nicer to some people, the idea though is that we want to reflect a lot of solar radiation. So a white version of this exact same cooler would work better. And then cities are starting to paint their roads white because ... And I'm going to show you guys this video, and it's going to make a lot of context or put into context what I'm talking about with the idea of albedo in cities. So your job right now is to sit back and watch the video.
2017 was the third hottest year on record, and based on recent trends, it's not getting cooler anytime soon. Some researchers are asking, how can we stay cool, especially in our cities? They're typically hotter than rural areas, but why? You can thank the urban heat island effect. On hot summer days, roofs, buildings, and other urban surfaces can heat up to 90 degrees hotter than the air. This creates islands of heat. One of the biggest contributors to those islands? Dark surfaces. Dark surfaces absorb all wavelengths of light and converts them to heat, so the surface gets warm. It's why your mom told you not to wear black during a heat wave. Surface temperatures can reach up to 150 degrees, and since asphalt is an insulator, it traps that heat over the course of the day. Then at night, when the air is cooler, the heat radiates away. Lighter surfaces, on the other hand, absorb fewer wavelengths and reflect the rest. That way, all that energy isn't absorbed, and surface temperatures won't rise as much. So, would coating our streets white help cool down our cities? Enter Jeff Lazar. He's the vice president of sales for GuardTop, a pavement company looking to cool off LA. Their solution? Coat the streets white.
We're seeing temperature difference right now of about anywhere about 9 to 10 degrees. But again, the temperatures are pretty cool outside right now.
When it's hotter, though, Jeff says the pavement could be up to 30 degrees cooler with the white coat.
Some of the pilot programs that we've done last year with Bureau of Streets and Services, LA City, I know they are, as well as we are, taking a look at the surfaces, making sure they're holding up, making sure they're still, doing what we said that we're going to do, and they are. And some of the neighbors are saying, hey, they do feel a little difference in this and that now. And if we can lower the temperatures by, the ambient temperatures outside by a degree or two, it means a lot.
That may not seem like a lot, but a report by the Environmental Protection Agency suggests that a 1.5 degree change could make a huge difference. Los Angeles could save over $100 million per year in energy savings and smog reductions. But what is the coating made of? Most other pavements use coal tar.
Some studies have been done on that where it's showing that it could have some carcinogenic effects.
But GuardTop says that its coating is made from recycled materials that don't have carcinogenic additives. Of course, LA isn't the only warm city in the world. Other US cities are also considering coating their streets, like Las Vegas. But officials there worry that it won't stick due to an oily road mix it uses to combat dry climate. And in New York City, volunteers have painted 7 million square feet of rooftops white, but that's only 1% of the potential roof area. It's clear that there's still a lot of work to be done.
I was never a big climate guy until we started getting into this product, but when you see what differences 1 degree can make in climate change, it makes quite a bit of difference.
Okay, so as I was showing you, is that the idea is that if we start painting roads white, or maybe even start working on things like in New York, they're focusing on painting the roofs of buildings white, we can really start lowering the temperature of these areas, which will have a huge effect on climate change. And also it said, we wouldn't have to use as much air conditioning. So, a lot of things are said about climate change that's all doom and gloom, but we really can start putting forward some efforts to making these things better, such as painting streets white. So what I would like you to do now is I would like you to take 2 minutes to go through your notes, highlight, organize, circle things that don't make sense. Make sure if things don't make sense, you ask Mr. Key for any help, but I'm going to go on and explain your summary. So how does thermal energy affect our everyday lives is our EQ. And once again, in order to be successful on your EQ, you need to follow the criteria for success. So I want you to describe how conductors and insulators affect how we store/cook food. I want you to describe how convection explains why the oceans are warmer at the top and colder at the bottom. And I want you to describe how albedo affects temperatures in a city. And so these are the 3 things that you're going to focus on in order to answer the Q. How does thermal energy affect our everyday lives? Because each one is an example. And so if you need any help on this, you just let me know. But good job getting your notes done. Like I said, it's the last set of notes for thermal energy. Good job, guys.